Hello. So let's take a look at example 310. So in example 310, we're asked, let's build upon the script you wrote for example 2.5 on page 40. And so essentially we want to compute the speed of water and ethanol over the range of 0 to 100 degrees C, building off of our code from example 2.5. So I'm going to head over to MATLAB. I've already gone to example 2.5. So, here it is, and I've downloaded and have downloaded the script. Okay, so I'm going to head over to MATLAB, and again, I just went to example 2.5 and downloaded already, and here it is. And so what I'm going to do is I'm going to build off of this, and I can do that a number of ways. Okay, but what I'm going to do is I'm going to go to the Editor tab, and I'm going to save this as, and let's call this, I don't know, Maxwell plot, say. Okay. All right. So we can update this documentation. So this is example 310. And so here we want to calculate and plot the average speed of water and ethanol using the Maxwell-Boltzmann equation over the range 0 to 100 C. Okay. Precondition. So now we won't have any preconditions. None. And postcondition. We'll return a plot. Plot with speed of ethanol, of water and ethanol over the range 0 to 100 C. Okay, and I'm going to tab that in, just make it look nice. All right, so I'm going to keep this code here, and then I'm going to build it up. Okay. So here it looks like I specified temperature in degrees C as a precondition, then I convert it to Kelvin. Okay, and so since I'm asked to plot over the range 0 to 100 degrees C, I'm going to create a for loop that'll go from 0 to 100 degrees C, and we'll just use an increment of 1. We'll use standard colon operator. Okay, eventually this will become easier in the next chapter once we deal with vectors, but for now, we'll keep it simple. So let's do 4, and I could even call it TC if I want. Okay, although a common index variable would just be I. Okay, so I'm going to do, and let me add end statement down here. I'm going to tab everything in. So T Kelvin is TC plus 273.15. In terms of Avogadro's number, gas constant, and KB, I'm going to bring that outside of my for loop. Okay, doesn't matter if it's outside my for loop or in it. It's just if it's in the for loop, we're repetitively performing this assignment each iteration, which is a little unnecessary. Just like calculating mass. Okay, let me pull that out. Okay, and let's update this. Okay. So here it's going to be defining constants, calculating the mass of a molecule in kilograms of water and ethanol. So let's do mass kg W for water. Okay, and so let's do molecular weight of water and ethanol in AMUs. So molecular weight of water is 18. Molecular weight of ethanol is 46. Okay. So actually, let me make this full screen so it's easier to see. Okay, so I've got my constants. Now I added molecular weights here as constants rather than being preconditions. Now I can calculate the mass of a molecule of water and ethanol. All right, so just updating our formula to here use the appropriate molecular weight. Okay, bam. I'll have my for loop. I'll loop over temperature from 0 to 100. I'll convert the temperature each iteration to Kelvin, just so I can use our equation as written last time. Okay, so this is speed in units of meters per second. The square root of 3 kT, the mass in kilograms. Okay, so let's update this to calculating the speed in meters per second of water and ethanol. Okay, so water. Okay, the only thing that we need to change is I need to use the mass of water. Okay, and if I were to, kick it old school to my Fortran programming days, what I might do is, this term 3 kb over mass appears every single iteration. So you might go ahead and pre-compute that up here, right? Or even go as far as to break up the square root. But we'll leave it as is for simplicity. All right, so this will create a for loop, which will loop over a range of temperatures from 100 to 0 degrees C. And for each temperature, we'll compute the speed of ethanol and water. Okay, cool. So in this problem, we're asked to plot the speed. So we're not dealing with vectors here at this point. So each iteration, we will plot, that speed for that temperature. All right, so I'm going to open up my plot window up here because I'll need to hold on. Okay. So, we could, just open up, say, figure 1, and then I'm going to do a hold on. Okay, so I'm going to change the setting of hold to on in figure 1, which will activate. And then here, let's add a comment plotting. So we're going to plot T in degrees C versus speed in meters per second of water. Then we'll plot same temperature versus speed in meters per second of ethanol. Okay, then at the end, let's add a label. So X label will be temperature. So let's do T. T. How do I want to do this? T in degrees C. Let's just do degrees C. Okay. Y label will be speed. So let's just do speed, and that's in meters per second. Okay, and let's see if it works. So if I move myself out of the way, okay, just to see if this works, I'm going to type Maxwell plot. Okay, and I have nothing. Okay, all right. So why do I have nothing? Oh, the reason I have nothing is because I didn't specify the the format of my data points. So remember, by default, MATLAB's going to plot a super tiny data point that you can't even see. This is, when I'm plotting individual points. Once I have vectors and I plot vectors, then if you don't do anything by default, it connects those tiny little points by a line, which I can see. Okay, so water will plot using black circles. Oh, actually, how about blue? Okay, blue water. And then ethanol will do, say, black X's. Now when I run it, it should work. All right, so now here I have water and I have ethanol. Okay, cool. Now if I wanted to fancy this up, so once I get it working, then I can play with it. I should be able to do, let's see, this should hopefully give me a superscript circle for degree C. Okay, so that looks good. Now the last part that's going to be a little tricky is we need to add a legend. Okay, so I'm going to try something first, which is going to be not going to work. Okay, so what it'll be tempting to do at this point is to add a legend where my first data set is water and my second data set is ethanol, like such. So if I run it, I get this. Okay, and in this case it works. Okay, so next we're going to talk about why this works. Okay, but there's my completed graph. Once I get it working, if I want to print, I could print, it's a dash EPSC I like to use, and then let's just call this Maxwell plot, and I'll automatically get the extension of EPS. Okay, so you'll see as I run things, like I like to add one small piece at a time. So that it makes it easier on me to troubleshoot, right? So, the last iteration I just got the print command incorrectly, but that was the only thing I added. So as soon as I saw an error message, I said, "Oh, Dr. Paluch, you've got the print command isn't working right." And so if I click on it, right-click, I can open outside of MATLAB. Okay. If you want to look at placement of your legend, you can do that. But also know too that MATLAB is such that in your interactive window you can move this. But if you were to look at legend, so if I look at doc legend, okay, there'll be an option to change the placement of my legend. Okay. So I'm bringing up the doc page. So remember, I want you to get in the habit of looking at the doc page when you go to learn something new. Okay. So here's an example of legend Southwest. I'm looking for the table that has all of set options. Yeah. Okay. So here's where you can change the location. Okay. So to go up top, location is a string when you specify it as an option, and then the options available are here. Okay, so when I put it in the top right, it was overlapping, but if you see there are even options, best to try and minimize conflicting with data. By default, it's going to put it in that top left corner. So if I go back here, legend, I can change the location, and if I do best, then best should place it so that there's no overlap, right? And it puts it in between. All right, if I'd want to say put it in the top left corner, that should be northeast. Okay. Northwest. Sorry, I was never a Boy Scout. All right, northwest. All right, so you do have some control over where you place the legend. Okay. Now, depending on how you set this up, so in this version, the legend works okay, but the subtlety, if I were to go back to the reading, is that this could be a little tricky. And so how it could be a little tricky when you go to add the legend is, here looks like you set it up exactly the same way. So where things can be tricky is it might be tempting to set up a for loop where you loop over ethanol and then say copy and paste and repeat by looping over water. Now, the challenge is when you plot, is when we plot single individual data points like we have here, is every time I call plot, MATLAB interprets that as plotting a new set of data. Okay, so if I were to loop over first and plot 100 data points of water, data sets, or 101 points, data set 1 through 101 would be water, and then it would pick up after that with ethanol. And so the challenge that presents is when I go to add my legend, here I'm telling it first data set's water, second data set's ethanol, right? And it works because the first point I plot is water, second is ethanol. But if you were to say loop over one and then loop over the other, this plot wouldn't work, or this legend command wouldn't work as is. Okay, but all right, there's me talking up a storm. There is exercise 10.